Okay, so as I mentioned already, we are going to be looking at perfect square trinomials today. So that's why we did all the exercises we did the previous day. If you were not here, make sure to get that worksheet from me. That is part of your table of contents. So what I've done is I've taken out that last constant term, and I'm asking you on the spell work to find a constant term such that numbers 1, 2, and 3 are perfect square trinomials. So I reminded you that a plus b quantity squared is a squared plus 2ab plus b squared. So we know, based on our discussions yesterday and from chapter 7, that a perfect square trinomial meets these two specific forms. It's either a squared plus 2ab plus b squared or a squared minus 2ab plus b squared. So in other words, I'm trying to find that b squared value. So how should I start number 1? Any idea? Well, do I know a squared? Yeah. So do I know the value of a? Yes. So can't I say 2ab, right? So what is 2ab going to be set equal to? 10. Yeah. So 10x, right? Well, we already have our value of a. What's our value of a? Just x, right? And then when we square it, we get x squared, yeah. So we have 2x equals 10x. So how do I solve for b? Yeah, divide both sides by 2. What I'm doing for you is the same process we're going to be doing when we do the square. We're going to be dividing and finding this. Okay. So when I do that, I'm dividing by 2x, not just 2, because I want to get the b by itself. And so b equals what? 5. Right. So 5 squared is 25. What I did was essentially complete the square. I found that square root. So I'm going to be doing the same thing for 2 and 3. What do I get for 2 and 3? What do I get for 2? 9. Right. And what do I get for 3? Well, this one's a little bit tricky, right? I get a fraction. Because this time for number 3, I'm going to set 2ab equal to 5x, just like Zach did in the beginning. I know that my a value is x, and I have my b, which is equal to 5x. I end up with a b value of 5 what? 5/2. Right. So when I square that, what do I get? Not just 25, but 25 over 4. Right. When I square a fraction, I'm squaring the 4. When I square a fraction, I'm squaring both the numerator and the denominator. Okay. Now the next part of this question says to factor it. So what is this factor to be? The first one. Well, something that meets this form factors to be that. Yeah? So what does that first one factor to be? Yeah, x plus 5 to the second power, x plus 5 quantity squared. What about the next one? X plus, oh, minus, right, it should be minus, right? How do we know it's minus? Because of the minus 6x, right. X minus what? 3, quantity squared, right. And then what's the last one? X plus 5/2. X plus tell you why we need to do that here in a minute. But again, this is what we'll be doing today, computing the square. We're going to be finding that p-squared value. Okay, any questions before we move on to the y part and what computing the square is more formally? Okay. Okay, we're going to start a new section of notes. Okay. So for those of you watching the video, this is 9-4, solving quadratic equations, and more specifically computing the square and how to use that to solve a quadratic equation. So essentially what we're doing is we are forming perfect squared trinomials. So it says for an expression of the form x squared plus bx, you can add a constant c to the expression so that x squared plus bx plus c is a perfect squared trinomial. So like what we did in the bell work, we are finding that blank space. This process is called computing the square. That core concept is re-explaining what I went over in the bell work. So it says find 1/2 of b, the coefficient of x. So if we look back at our first example, and you don't have to write this down, you can continue writing down the core concept if you're in class writing this down. But I'm just going to explain verbally, again, what we did with just the first example. When we were looking at x squared plus 10x plus this blank, I said take 10x and set that equal to 2ab. You told me that you knew what the value of a was, and so we just replaced it with x. The first thing that we did was we divided, right? We divided by 2. Divided by 2x. So that's what we're doing when it says find 1/2 of b, the coefficient of x. So we're just looking at 10 really, and dividing that by 2 and getting 5 as a result, right? So we've completed step 1 by getting that 5. Step 2 says square the result from step 1. So that's what we're going to do. We're going to move to squaring it, and we get 25. And then we finally complete it with step 3, add the result from step 2 to x squared plus bx, which is what we did in the bell work, and that's how we got 25. And we completed the square. Does that make sense? Good. Alright, for those of you watching this recording, it says complete the square. So it's essentially what we've already been doing. This time you can streamline the steps. So again, we are setting it equal to 2ab, but according to our steps from the last slide, you can just take that middle term instead of dividing by the entire 6, saying 6x divided by 2x. You can just take that coefficient 6 and divide it by 2 because the x's will cancel. So we're going to take that middle term divided by 2 and then square it. And we square it and we get 9. So you should add it to the end and you get plus 9. That is now a perfect square trinomial. Second part is to factor it, and that factors to be what? X plus 3 quantity squared. Right. Same thing here. Take that coefficient, which is negative 9. Divide that by 2. And then we're going to go ahead and square that, right? So it's okay if we end up with a fraction. I'm going to square that fraction. And when do I get it? Yeah, when I square that. 81/4. Okay. And I want to leave it as a fraction because, again, that's going to make it a little bit easier for me to factor that out and say, hey, I have a perfect square in the end. So that factors to be what? X minus 9/2 quantity squared. Okay, so why do we complete the square? Let's take a look. Okay, so there are two ways that we looked at solving quadratic equations. One was by factoring, one was by using square roots, and another is by completing the square. you not have to write this next slide down. So we've already looked at that. So I gave this before, and I said, okay, this is when we factor, when things are easily factorable, when it's already factored, etc. If we don't have a middle term, then we use the square root method. Now, why is completing the square important? That's another way to solve quadratic equations. And you can use this completing the square to solve a quadratic equation if you're very comfortable with it, instead of these other two methods. But mainly, we use it when we're graphing, when we're told to put something into vertex form. Now, when we get into the graphing chapter in chapter 8, you need to know how to complete the square in order to make the graphing part much simpler, because it's going to allow us to get the vertex very easily. Again, we have an h and a k, which we're used to seeing with the different graphs that we've been working with. Absolute value graphs, for example, we had an h and k. With exponential functions, we had an h and k. And again, when we graph parabolas, we're going to have h's and k's. So completing the square allows us to put something into a different form that allows us to look at the vertex right away. So we do need to know how to do that. So it's more for graphing than anything else. Any questions about any of the three methods so far before we go into actually how to solve when completing the square? Okay. It says solving a quadratic equation of the form x squared plus bx equals d, and then I have an example here. There are a number of ways that you can try and solve this quadratic equation. Part of the reason why we give you so many different ways to solve quadratic equations is that one way may not always work for you. Okay? There are some that are very easily factorable. Like that's actually pretty easy to factor and solve. There are some where using square roots makes it very simple. And there are some where you don't even want to deal with the constant. You can't think of something that multiplies to be the constant adds to the middle term, so you complete the square. Okay? And then we're going to look at another formula, the quadratic formula, next section, which is yet another way to solve quadratic equations. So there are numerous different ways, and you do need to have mastery of all of them, so that when you get into algebra 2, pre-calculus, calculus, etc., you have an array of tools that you can use to say, okay, I don't know how to solve this by factoring, so let me try square roots. Okay, that didn't work. Let me try by completing the square. That didn't work. Let me try the quadratic formula. Okay, so, and then at that point, okay, maybe it's factorable. Yeah. So, let's look at what we're used to first. So before I wanted you to solve it, what would you do when I said, okay, I want you to factor this? What did you have to do first? Add 15, right? So, like I said, this is pretty easy to factor, but I want to start with an easy one so you can see how that compares to completing the square. We have that perfect, and then we set up our little x method. We don't have to use our box or anything because this is a coefficient of 1. I put 15 on the top, I put negative 16 on the bottom. Well, multiplies to positive 15 and adds to negative 15 and negative 1, and then I factor this to be x minus 15, x minus 1 equals 0, and I get what for my x values? 15. Okay, that was easy, right? Well, we're going to look at completing the square. We're going to get the same answers, but again, when problems get more difficult and aren't easily factorable, then we might want to complete the square. So, to complete the square, this is what I do. I am going to just look at this part. Okay? The rule in mathematics is whatever you do to one side, what? You have to do the other side. So, I'm going to follow the rule. I'm going to take that coefficient of the middle term, which is a negative 16, and I'm going to do what with it? Divide by 2. That was the first step of completing the square, right? Just pretend like we're doing the bowels again. Put a blank here. So here's what I'll write it down. Actually, this is more helpful to me. I always do this when I'm completing the square. X squared minus 16x plus blank equals negative 15 plus blank. So I can add something here as long as I add something here, right? Yeah? So this is just our bell work, right? So 16, negative 16 divided by 2 is negative 8, and then when you square that, you get 64. So I square that and I get 64. That is now 64. And so, this is 64. So if I'm adding 64 here, that's okay as long as I add it over here, right? Well, what is this? A perfect square trinomial, yeah? So what is this factor to be? Well, this factors to be x minus 8 squared, right? So I'm just doing what I did in the Bower. I get that last term, and then I factor it to x minus 8 quantity squared, yeah? Are we good? Okay, what's 64 plus negative 15? 39, right. How do I solve something like this? Ray, how do I solve something like this? Yeah, I could square root it. What happens when I introduce a square root? Is it just 7 or is it plus or minus 7? Okay. So what am I doing? I'm completing the square. I'm doing what I did in the Bower, then I'm factoring it, and I'm actually solving it by, so yeah, more steps. But in cases that are very difficult to factor, this might be your only choice. Yeah? So now I have two equations. X minus 8 equals 7, and x minus 8 equals negative 7. And then I just add 8 both sides, and I get exactly what I got before. I get x equals 15, and x equals 1. I just solved that quadratic equation by completing the square. So, to kind of put everything together, we're doing what we did in the Bower with a couple added steps of solving for that square root. So I'm doing what I did in 9.3 once I did the simple square trinomial. Do you have any questions about that? It can be a longer process, but it's nothing that you haven't done before. Okay. Alright, so one thing that we have to notice about completing the square is that we don't actually set the other side equal to 0, right? We do that when we factor, but we don't do that when we complete the square. So that might be helpful for some of you that don't like to do that when you complete the square. So just take it as it is, and then we're going to solve it like we did the Bower. I'll take x squared minus 2x. I'll add, it's always add. Always add a blank to both sides. Now, you explain to me the process. What do I do now? Yeah, I take negative 2 and I divide that by 2. I'm just looking at the coefficient, and then I can take some shortcuts. So negative 2 divided by 2 is going to be negative 1. Okay, what do I do next? Now I square it, and I get what? Positive 1. So I add 1, and I add 1. Yes? So what have I just created? A perfect square trinomial, right? Tri meaning 3, right? Don't forget, trinomial means 3 terms. So what does this first one factor to be? This side, on the left side. Yeah, x minus 1. Where did you get the minus? From the minus 2. This is of the form a squared minus 2ab plus b squared. Okay, so now that's squared, and that's that equal to what? 4. Right. Now what do I do? Now I square root it. So again, this is just that extra steps. Most people are good from here to here, but they don't want to do this part. So you square root it, you get x minus 1 equals what? Plus minus 2. If you didn't get that on the quiz, make sure you remember the positive negative. You will miss points. So, yes. Did you get the 4? I got the 4 because I took 3 and I did what to it? I added 1. Remember, whatever I do to one side, I have to do the other. Okay. So x minus 1 equals 2, and x minus 1 equals negative 2. And what do I get from my values of x? Yeah, negative 1. Okay, do you have any questions on completing the score for that first one? Sometimes your answers are not very nice, and that is the case with this next one. We're almost done here. We have one more problem to go after this one that we got to show you. If we look at this one, we're going to complete the square like we did before. So walk me through the process. M squared plus 12m plus the length equals negative 8 plus the length. So what do I do first? Yeah, take 12, divide that by 2. I get 6, and then I square it. That's okay. 36, 36, 36. Yeah? So, now what does that factor mean? Yeah, m plus 6 quantity squared equals what? 28. Okay. 28 a perfect square? No. So, I'm still going to do what I have to do next, which is what? Square root it. And this is where it gets a little tricky. So I introduced the square root, so I have a plus and minus, right? So far I have m plus 6 equals plus or minus what? Square root 28. Can I simplify that? Square root 28? Always simplify square root 2. Well, let's see. Can I factor change? What's 28 break down into? 74. Can't I break down 42 and 2? So can't I simplify that? So doesn't this equal m plus 6 equals positive negative 2 root 7? Yeah? Okay, so we're fine here. I think we're fine adding the 36 to both sides. Yeah? And we have to square root it. We're getting better about remembering our plus or minus because we are introducing the square root. So we have to have a plus or minus. Now this is the other part. There are a lot of things we have to remember. Always, if you have a radical that's not a perfect square, see if it can break down even further. Simplify it. So I did here. And now to solve for m, what do I do? Subtract 6. So my final answer, if it's not a decimal approximation, is m equals 2 square root 7 minus 6. And what's my other one? M equals... No. Negative 2 root 7. The 2 root 7 is what has the opposite sign. Because you have the plus or minus attached to that 2 root 7. Alright. I think what I've gotten as far as the feedback is it's just a lot of steps. It's not very difficult steps, it's just a lot. And there's not really an answer I can give you other than I know. But you can do the steps. It's not an idea. Any questions? Alright, we're going to end. This problem says you drop a feather from a height of 160 centimeters. The function h equals negative 16x squared plus 160 represents the height, h in centimeters, of the feather after x seconds. How long does it take the feather to touch the ground? So this was very similar to a quiz question. So, if I wanted to touch the ground, what height am I looking for? Height of what? 0. So what am I going to replace h with? I'm going to replace it with 0. Why 0? That's the height when it hits the ground. On your step up to writing, you need to be able to explain that. So, when you explain that process to me, and that's the point of step up to writing, right? It's to be able to communicate to me that you know actually what to do. Because we've sort of fostered this idea that I'll tell you what to do and you memorize the process. No, you need to learn how to tell me what you're doing so that I know you have a concrete understanding of the concepts. That you understand that 0 means that the height is 0, which in turn means that it's in the graph. So 0 equals negative 16x squared plus 160. So that's what you're going to talk about when you talk about right. Okay, first of all, how did you notice that equals 0? And then, what do you do next? How can you solve this? Well, there are a couple different ways. You can either factor it or solve by square roots. Which would you rather do? Solve by square roots. Okay, what's an indication that you might want to solve by square roots here? There's no middle term with this next step. Now you could factor out a 16 and solve it that way if you want to, but let's just solve by square roots. I'm going to do that by first doing what? I have to get z equal to a number other than 0 here before I take the square root. So what am I going to do? Subtract 160, right? Subtract 160, subtract 160. Again, you can do this by factoring if you want to. So you got negative 160 equals negative 16x squared. How do I get rid of that number in front of the x squared? Divide it. Divide both sides. Perfect. So, when you do that, and you're solving by square roots, you get x squared equals what? Yeah, 10 is 10. Okay, so where do I go from here? Now I'm going to square root it. Introduce a square root, introduce a square root, so x equals plus or minus square root of 10. I can't break that down, right? No. Is it going to be both answers or just one of them? Just one. Which one? The positive. Why the positive? Right. It doesn't take negative seconds. But we're not looking at negative time. In your step of writing, you need to explain that. Right? That we're looking at a time which is always positive. But we're gonna approximate this. How long does it take the feather to touch the ground? So about how much? Put square root of 10 in your calculator for those of you who have it. And tell me what you get. Yeah. So about 3.16, about 3.2 seconds. So you state at the beginning your green light. It takes about 3.2 seconds, and then you end with it takes 3.2 seconds. So your task tonight is to, we've already solved it. We've already verbalized to me how to solve it. Now I need you to express exactly what I talked about in writing. And that's what you want. Okay? This homework that I'm going to assign you, you have 2 days to do. The book work, you have 2 days. It's today's homework and tomorrow's homework. So do the step up to writing first, and then if you have time, leftover time, do the math assignment, which is right here. I realized I was missing one bell word, so I had to revise myself. So far, for 9-4, you should be able to do 6 to 22 even without any problems. So if you want to go ahead and get those done tonight, you can. But that step up to writing is due and something I will collect tomorrow because I need samples. Thank you. Try your best, please. You are encouraged to highlight or use different colors if you have them.